Okay, so here's some examples of conjugate pairs. So what do we notice about those pairs?
They got the same absolute values.
Very good. Can somebody say it a different way? That was very good. Yeah, I don't know if everybody understands what you just said. They're opposites, yes. Yes, what you said was fine. It was good. Very good. So they're opposites here. What else besides them? Besides the fact that they're opposites. Anything else that you notice about them? Are there any integers there? No, neither one is integers. So what we have, so let me show you another conjugate. We're going to do really simple conjugates in here. If you go on to calculus. So these are also conjugates, so they aren't always opposites. What they are is, what happens if I take 3i, negative 3i times 3i? What do I get? What do I get when I multiply those? 3i times negative 3i. 9i
Squared.
negative 9i squared. What is I squared equal to? Negative 1. So this is negative 9 times negative 1, or 9. So the I goes away. It becomes a rational number, an integer. So what if I take negative square root 3 times negative square root 3? Positive, excuse me. What do I get when I multiply those? What did you say? 3. So since it's a positive and a negative, this is going to give us negative 3. So you might have thought in your head negative square root 9. Okay, because you can multiply the 3 and 3. But square root 9 is 3. So it's equal to negative 3. So notice that square root goes away. So that's what makes them conjugates. We want to have a polynomial that has coefficients that are rational. What's rational? You know, we talked about integers, we talked about conjugates, a lot of vocabulary in this. So, rational number would be anything that can be written as a ratio of 2 integers. So, essentially written as a fraction, like 3 over 4 or 111. The number 111 could be 111 over 1. So, rational numbers are numbers that can be in a fraction here. So we want to find on this one here, when we have the conjugates, then we get those numbers for our coefficients, those nice numbers. So what we want to do on this problem here is we want to find any additional roots. So the conjugates come in pairs only. So if I have an 8i as a solution, I also have a negative 8i. If I have a negative square root 3, I also have a square root 3 as a solution. So would there be any other solutions here for this number? Any additional? Take a look at that one. What's my conjugate for that? The opposite, which is just I. I know you're thinking about what is I is square root negative 1. We'll just do this I. So with the I and the square root, we want conjugates. Okay, those have conjugate roots. So any conjugate roots for number 5? Any additional roots?
I don't see any. Just kidding.
Square root of 3, so positive square root 3, and then someone besides Derek, what would be another one? Because there's another one for number 3.
5.
Positive 8i or negative 8i? Negative for this 3i. Does that make sense? Oh. Okay, good. So that negative 8i then would be an additional root. Does that make sense? We didn't take the opposite of negative 5 because that's not, we don't need that. We don't, it's not one of the conjugate pairs. It's only the square roots or the i's. They're going to have conjugate pairs. So, on number 4, do we have any additional roots? Yeah, you're good. So Dexter just said there's already a pair there, square root 10 and negative square root 10. So we didn't need to write it. It's already there. So what we're going to do is we're first going to write it in factored form, just like we did before. So we have x. What's the relationship? X. Let's have this group back here. What's the factor for the 3? X. Good. X minus 3. And then what would be the factor for square root 10? And with an x there, where would the x be? X. So just like if it were a regular number, it's going to be x minus square root 10. And then x plus square root 10. And we're only putting it in factored form. That's the factored form. Does that make sense? Okay. Do we have any additional roots for number 5? Here, any additional roots for number 5? Very good. So negative 2i, and what else? And positive square root 7. So we have a conjugate pair for the negative square root 7, and we have a conjugate pair for the 2i. Does that make sense? So now we want to write it in factored form. So here in this group, write it in factored form for me. You can do the 3/5 last if you want. Good. Okay. So I'm just going to put the other 2i next to it. It doesn't matter, but x minus square root 7. X plus square root 7. And then you want to do the math on the side for the 3/5. What would we do first?
5x minus 3.
Good. So we get 5x equals 3. If you can do that in your head, that's fantastic. So 5x minus 3 is the last factor. Does that make sense? Okay, what about for number 6? Any additional roots on number 6? There's none, that's right. We don't have any, an I or a square root. So we go straight to our factored form. So what would our factored form be here in this group? Tell me the factored form.
X plus 5. X plus 1. Small x minus 3.
Good. And if you need to do that on paper, that's okay too. He was able to do that in his head. Okay, do you need me to show you where we got the 4x minus 3? Anybody?
No.
Okay, on to the next one. So what do you think we're going to do for the next example? We're now going to write the polynomial function. We have to have an integer square root. Essentially, we're putting it in standard form. So any additional roots for number 7? This group back here. That's right. So now you guys put it in factored form for me, that same group. Yep. Okay, now we got to multiply this out now on this one. What do you think we should multiply out first? Yes. Okay. So you don't have to. It's going to make it much easier for you because remember the reason they're a conjugate is that cancels out that I when we go to multiply it out. So if I multiply this out, let me use a different color. I get x squared plus ix minus ix minus I squared. So the ix's cancel, and what is negative I squared equal to? The negative 1, the opposite of negative 1, which would be positive 1. So this is x squared plus 1, and we multiply it by x plus 2. So this group here, tell me what we get when we multiply it out. Good. Good. And then plus 2. So we want to write that in standard form. So x to the third, and then we'll put the 2x squared next, plus x plus 2. Does that make sense? Okay, so on number 8, that one's just like what we did yesterday. Do we have any additional roots? No. Can we skip it and go on to the next one?
Yes.
Okay, do the next example. Okay, so you have to put it in factored form, and then you have to multiply it out. So, okay, here's the next one. Okay, so any additional roots on number 9? Square root 10, that's right. A positive or negative? Negative square root 10. No. Hey, put it in factored form back there in that group. Put it in factored form for me.
X minus square root 10. And then positive
X plus square root 10, and then we have one more. That takes care of the 0.
Oh, I got you.
X plus
No, no. X.
Anybody in the group
Come
now?
on, guys. Come on. Come
No.
on. Come on, guys.
Okay. It's just an X. Does that make sense?
Oh, yeah, that was my second thing.
All right, that's a little trickier. So what do you think we need to multiply first? Yes, not the X. I wouldn't. I mean, you can. I wouldn't.
Oh, you said that.
I would multiply these two first. Okay. So multiplying these two out, we get x squared minus plus square root 10x minus square root 10x, and then what's negative square root 10 times square root 10? Let's take root back there. What do we get? We'll take negative square root 10.
Or negative 10?
Negative 10. That's right. So we get negative 10 and then an x there. So these cancel. We have x plus 1 times x squared minus 10 and then times x. So we could, if you wanted to, you could multiply one of them by x. I like doing it last. So now we're going to multiply these here. Let's see. This group here. Tell me what we get when we multiply these. Good. Good. So we still have to multiply it by x. So we have x to the 4th. And I'm going to put it in standard form at the same time. X plus x to the 3rd minus 10x squared minus 10x. You want me to do another step in there without confusing if I switch the order? Okay. So I'm going to ask you to do the U try next, and then I'm going to come back up and talk about number 10. Go ahead and do the U try, please.
No, all gonna fall out. No. No, I just put all of it right here. Recently, all I'm a full right. I wanted to do
He has it too.
He was just messing. Whoa. Me and my friend, no, I have pretty bad stuff like that. No, I can't. Is it like you always do?
No, it just.
No, she always says.
What's the most important?
White screen. You guys want to play with like
No, I'm.
you got flames going up.
I said, is there room?
This is dangerous. World War II. It's a World War II. No.
World War
II. Hey, when? What's the other one called?
What's the one that's a big one before that?
Yeah, wait, yeah.
Wow.
Was it?
What is it? Wow.
Is that World War II?
Okay, this is what you should get for the U try. I'm just going to quickly talk about number 10. Any questions on this before I move back to number 10? Okay.
We're good.
Any additional roots here?
Negative 3i.
Negative 3i and? Yes, negative 3i and negative square root 5. So my factored form is going to be x minus 3i, x plus 3i. and x minus square root 5 and x plus square root 5. So which ones would I want to do first on that? The two ones with the square root, multiply these two. I'm going to skip some steps and just show you what you get. You get x squared minus 5. And here on this one, this would give me x squared plus 9. And then I multiply it out one more step to get to the end.